you may need.
When can we use the low frequency? What test?
Probably on this test, if maybe a very high temperature and a soft material, so it doesn't take not as much load to apply the.
Yeah, it will be not take the more load.
Yeah, because the dynamic modulus test, the way they set it up was they're trying to target 100 microstrain.
Sir, how minimum is how much how many kilometers is load?
The load cell is a 15.
Minimum and maximum 50 kilometers, 0 to 50 kilometers.
0 to 15, yeah.
0 to 50 kilometers.
So at the higher frequencies, it takes less load to apply. Where the colder samples and the slower frequencies, you might put full 15 kilonewtons on the sample to try and get. They're trying to target 100 microstrain on the sample.
Now the temperature will be increased for the inside the chamber. Right?
Yeah. So if we open,
so I see this one now it is increased.
it's going up. Yes.
Up to 32, when it will come up to 32, only we can
Then it'll hold.
the tester.
Yeah. But we'll take this up and down a few times so we can show inside.
Yeah.
So basically, when you're running a test, so you have these two
Should be green.
green,
Okay.
and you'll also see if we turn off here, the bottom of the software there's a what we call a status bar. So this indicator here is low pressure.
Yeah.
So when we turn on, so when this one is active to high pressure here, this goes off. So if you see something flashing here, then it's an indication there may be something wrong in the machine.
Or a system.
Yeah.
So for this test, we will select a high.
Yeah. In general, on all hydraulic tests.
So low condition where we will put it?
Probably on the YouTube 25, if we're going to do some indirect tensile testing.
That is low condition.
Yes.
Tensile testing is low. We will select low conditions and.
Yeah. So if it's
for
any.
AMPT, we will select
Yeah. For this one, have always high.
Okay.
And for that machine, depending on
That test.
if you're doing an indirect tensile test, it takes a lot less load to apply than a say like if you're doing the loading on the top of the sample.
Okay.
And you'll get as you do more testing, you'll get familiar and you'll sort of know if I run high pressure or low pressure. So to raise the cell, so we can get the sample in, there's two buttons on the screen here for raise lower. So if we click the raise,
It will become up.
if for some reason you click the raise and the cell doesn't go up, then the first thing you do is to check you have the air compressor on, because this needs the air to push up the system. So this goes up. So from here, see you actually feel the warm air blowing up through here.
Yes.
So this is
Hot
the
air will come out.
yeah, and this is just a return path. So the air can flow through the system. So when you're doing a test at high temperature, you want to get this
coming
air.
out or sucking now?
No, coming on.
This is coming up cool air or
That's a return. So
Sucking.
yeah, sucking. So it's a flowing.
not sucking.
It might be a little.
It's not sucking.
Yeah, it might be a little bit. But if you feel this one, it's a lot more higher.
This will be up. That is low. So how we will first to be how we suck.
So with these transducers, there's a little red mark here.
Yeah.
All you do is match it onto the transducer there, and you'll see the different colour codes on the thing. So each transducer matches each position. So they just press in. Ready to try this one? And to remove, it's just very easy. Just pull up. So here's the sample. Here we have a top platen and a base platen. Depending on the test requirements, there may be a for confining, you put a membrane over. You can put the membrane on here. These targets, you'll see there's see, if these are in one direction, the gap between here is a different height. So if you've got a membrane on, you're going to have more area on here. So when you're putting this target on, it gives you a different spacing. So normally you'll have, if you're not using a membrane, I think normally in this direction have the black points on the outer side. So maybe have some practice putting these on. And if you have not put enough glue on, sometimes when you're putting this on, it might break the glue. So again, it just comes down to practice. If you keep falling off, then you know I'll have to put more glue. And then on these, there's a little dimple hole there, so you see if it's all working correctly, that will sit inside that. You see the hole there, so it should sit like that. That normally sits in there.
Okay, there is a two types. This one black color type and that one is...
yeah, it just gives you a different spacing between, if you're using a membrane, the membrane will stretch a bit, so it will be a smaller gap.
That means this one also black color one for this side and silver, the steel color of this side, right?
Yeah, well, normally with these, this gold piece is a locking piece, so you can use this to adjust the space. Yeah. So when we come to the software, we need to set up the transducer. So when you're running the test,
should be touched both sides.
The transducer will be within its operating range. If it's near one end of the stroke and you run a test, you may lose your signal on the transducer because you've gone out of range. So we'll adjust these when we do a test later. So this one here is for locking, and this can adjust the height. So when you've sort of got your position, you lock that in and you can't turn.
So you're doing before the start of the test?
Yeah.
But for now, when you're putting it, do not lock it first?
Yeah. So it's normally, because it's a fixed spacing, usually once you've set that up, you don't need to change the gap. So that's some practice. And if it's incorrectly, if you pull on this, it wouldn't come out. If for some reason, say it's sitting a bit loose, or not sitting correctly, it'll just fall out. So you'll know if it's not sitting correctly.
If it is little full, it will not come out.
It shouldn't. If you pull hard, it will come out. But
but little full, it will be not come out.
Yeah.
That's been correct, right?
Yeah. So it's sitting nicely like that. It's in the two holes, and
Three times same we have to do.
So we have these are set up at 120 degrees apart. So if you were to go,
so this one same upside like that, same.
And see, this can only go one direction. See how there's a plate? Yeah.
Should be this one, this direction.
Not should come.
So other one here, it is where it is.
I think on the bench. So there's.
In the box.
top button. In the dynamic modulus test, they recommend to put a ball on the top. So if your sample is not perfectly flat, this ball here will give you alignment. Yeah. So if you don't have this in, then it's assuming that you've got a very flat, smooth sample. So normally for dynamic modulus testing, they use this. In the flow number test, they take this out. So from here, you can put the sample in quite simple. And you'll see. And on the bottom of this platen, there is a little bit of a groove, so it will sit quite nicely in there. Yeah. So you'll know when it's sort of in position. It'll sit nice on there.
So this one and this one should be straight.
Yeah, it does not matter. This is for if you were using a membrane for confinement. You put a membrane on, and you can use this hose and a little bubble chamber here, so you can check for any leaks in the membrane. So if you're doing just unconfined testing, you don't need a membrane, you don't need to connect this up. So for the moment we'll just run with no membrane.
Like a tri-axle.
Yeah. And always good after testing, just to clean the surface on here. Some people put some lubricant or a bit of rubber membrane in between here to stop friction. Do you know why they put that in?
I see the rubber pieces there inside.
Was there some rubber there? Okay, if we have some. The height? 150.
150.
And 100 by 150.
100 by 150. This one for what?
No, they're for the membranes, but sometimes they may cut a membrane piece and put it in here for running the test as well. So from here, do you want to put the sample in?
Also to need it to the sensor.
Now before we put the transducers on, we'll just go back to our software. So we've had the buttons here. If I start a new test and press levels, so the levels is a screen which shows the positions of the transducers. So if you look at the green transducer, if I press this in, see how it's moving?
Yes, I see.
So when you're preparing a sample, you activate the level screen, and then by putting these on, you can see the position of the transducer. So at the moment we put the transducer in, but it's showing full range. So we need to adjust this height here. So we loosen the gold one, and we can adjust this up a little bit. Then we can lock, and we can put back in. See now the transducer.
Yep. But it should be the 0.
Our transducers, the 0 point is always in the middle of the transducer. So this is calibrated plus minus 0.5 mil. So when the transducer's here, it is plus 0.5 mil. If I press them fully, this is minus 0.5. Yep. So the 0 point is in the centre. So for this we can adjust this a little bit more. Went the wrong way. So
that direction. Right?
So I need to open this one. So So maybe you can try this one, put that one in, see how it...
Check first.
Yep. So if for some reason the transducer gets damaged and you're pressing in and out, it does not move, it could be a bent shaft or something.
Another one.
Now, that one fixed that blue color.
Yep, that's
4.095, right? It will be little bit down.
That's okay.
Adjust mo na siya ng konti pataas.
Ah, 09.
0.0 ba dapat?
Oh,
Naka-adjust na yung dati eh.
Now it's
too much.
0.061. Very low or?
It's does not have to be exact. You need to work out how much movement the transducer will do. Because you're targeting 100 microstrain, it's only a very small deflection on the sample. So as long as you're within the middle of the transducer, you do not need to be exact, but around that area, it should be okay. So this top one here is the displacement transducer, which is inside the unit. You'll see if I do this, what we talked before about jogging, if I jog this up and you watch this, so you can see that moving, and this is rising. But this machine does all that automatically for you, so on this one you don't have to worry about rising up the sample. So over here we can...
What about the top one? So now
So
these things
the green
are
light
automatic
on.
or?
Yep, so
This top one is automatic, sir. This one.
it's displaying our displacement transducer. So when this test runs, it'll automatically go up and down, depending on, when you start the test, it'll rise up.
What about the confining and the
Yep. So the number B is the load cell. So the load cell is mounted underneath here.
Under this sample.
And then also in this machine, when you put a sample on, it's going to be sitting on the load cell. So the load cell will read the weight of the sample.
Yeah.
This machine
gives some load of the.
Yep. This machine will automatically zero out.
It will get the zero, right?
Yep. Yep.
Before
Where-
starting the test, it will get the load cell automatically.
Yes, it automatically zeroes in this test on these machines. On the universal type U1025s and those types of machines, sometimes you have to do that yourself. So this is a lot easier to operate and use. And then the third one is the confining pressure. So the confining pressure is applied through this port as well as where the temperature circulates. And you'll see the temperature probe.
20.81.
Yeah, so
Yes, same.
Yeah. So because we had the chamber open now, it's trying to cool here and also trying to heat inside here.
20.9, 20.8.
Okay, to lower the cell, you can press the lower button. Now the cell will not automatically fall down. For protection to stop if someone's hands are inside here, what you must do is press the interlock buttons. So you need to use two hands to lower it. That stops you from having a hand in here and maybe someone...
Manually this one can go.
Yeah, so you have to hold these buttons down.
Both buttons together.
Yeah, so if you hold...
So that your hand is not...
Yeah, so you, it's not coming down very, very fast or a lot of weight, but you can still, even if the
To
transducer...
open, it can be also one to open.
One raise is automatic, it just goes up. So if you press the raise...
That is for safety.
Yeah.
Now this one we will make
Okay.
It will be go automatic.
Then close to close.
This one lower.
when that comes down. So when you are familiar with the test in the standard, all this has to be done within 30 seconds. Putting the sample in there, transducers on.
Yeah, that's all things we have to done within 30 seconds, right?
Going by the standard. So that way.
So that one we needed practice.
Yeah.
Once you get the sample from the conditioning unit, 30 seconds.
Yeah, that's when it's example, sir. Example, we will cut the core sample. We will put it in the oven to get the
temperature.
Test in temperature. Then immediately we will replace the sample. No, we have to fix it before the glue and put it in the oven. Then immediately we will get the sample. Then we will fix it those sensors, and immediately we have to put it in. Increase our temperature, condition temperature, whatever the testing example, 40 or 45 or 50.
Exactly. Yes.
Whatever it will be, keep the same temperature on the sample until the testing finish, right?
Yeah. So now you'll see our temperature is increasing again.
Yeah.
Close the chamber.
So example, now I have to test sample. Example, I will put it in the oven.
Yep.
After that, whatever my target temperature, it will get the sample. Before I have to start the machine and should we make it warm inside the temperature or
and also
after put the sample.
And also depending on how long you have to condition the sample. Is there specifications for conditioning times or 1-2 days or whatever? So you may have to have a sample conditioning. So you'll need to review the copies of the standards and get familiar with the steps of your preparing for your test. So you'll see also the displacement transducer colour is the same on here as on the transducer, so very easy to check which is which. So
then we can identify the project name and other details we can.
so on this test, the first section, you put a project name, the operator, any comment or information about the material. This tells you where a template.
The file is.
So what you can do is set up common parameters which you don't change all the time. You can save them into what's called a template file, so you don't have to re-enter everything continually. You can just call up the template, and then just the main information you need to do is enter information about your specimen. Okay, so say if I just change something, you'll see this T here is a template and a cross. That's indicating that the template you've saved on the computer is different to what you've set at the moment. So if you wanted to save something different, you would go File, Template, Save Template As, and you'll see we have a list of predefined templates. So if you're doing a common test on certain conditions.
Yeah, here it is 4 to 15 degree, 15 to 40 degree, 40 to 60 degree.
Yeah, so we had
that is 3 type of.
Yeah, so we generated these back at IPC. Okay, and then you can modify.
Now example, I want to do the between 40 to 60 degree. How I can select the file here?
Okay, so this is for saving. If we cancel and not save.
Yeah, because of it is wrong.
If we go File, Template.
Okay.
Open
template file. Template file.
We say we don't want to change anything at the moment, so we go no. So if we call up this template, it'll load that template from the computer, and at the moment this is a green
to the
tick. So it indicates that your settings on the screen are the same as what you have in your template.
Now it will be range of 10 to 40 degrees.
Yeah, this one here, in this section here, the setup parameters is where you can enter your target temperature. So for this one, if we're going to go 32 degrees, you would enter.
Yeah, manually we have to enter here,
yeah.
Right?
Just again, just close again.
All sir?
Yeah.
I will close here. Yes or no? If you want to close application, yes.
Yeah,
we will close
you
it.
can leave the machine running
Yeah,
Normally, if you're closing the software down, you would shut the machine down.
Yeah. Then sir, this one,
Six.
right? UCTS 6.
Your TS6. Yeah.
After press the OK, then will come. After that file, we have to open new, right?
No, no,
New.
yeah.
Or you can click on here too. New.
Yeah. Also from here also we can get it.
Yes, there's two ways.
Yeah, new. Then we will enter the project name and operator name and other thing. And then there is a level. We have to check on the level.
Yeah. So when you're setting your sample up, you use this screen.
Yeah, and also this one hydraulic pressure will be high.
Yes, when you first start.
Hydraulic pressure will be high.
Yeah.
Then everything it's.
And then you can go into
After you fill this point,
Then sir, we have to enter the levels.
level is already entered. Okay.
Yeah,
So,
new one. After that, we
so
will
you
go
raise
for-
and lower. You use
Yeah,
these
yeah.
buttons.
Yeah.
Okay.
Then we will example project name. We will put.
Trial.
Oh,
No, no. I here.
then operator name. No. Okay.
What's your name?
Okay. Then we will put some
Comment.
comments on the sample.
You can,
Example.
yes. Yeah.
We are there.
Yeah. So then next you would go to the setup and control.
Then sir, this one we have to select the temperature file, right?
Well, this is where you can save this information into a template. So maybe if you go file,
File
template,
open temperature.
Save template.
Open, right?
No,
No, that's
save,
not.
save as
Yeah.
now.
so cancel,
Cancel.
file, template,
Save as.
Save.
save as.
If it is even new file.
Yeah, it's
Yeah,
a new one.
yeah.
that
you can
means
create a new
There
file.
is already inside 3 files, right?
Yeah.
So you can create a new one for
You can
your
make-
specific.
Yeah, otherwise the whatever the save file, how we will use it for this one? We will have to open the save file or first
The last template file is automatically loaded.
it automatically will come.
Yeah. So when you hit new, whatever file is in this list here will get
It
loaded.
will become control setup, right? Here.
So it's good when you save your own template files, give them a nice long description on the file name. So it's very easy to recognise which template you want to use. Instead of having like template 1, template 2, template 3.
You put everything there.
Yeah, put
Yeah, beginning we will save it.
like we had temperature range, or
Yeah.
like we.
Oh, okay, sir. Now we have 3 temperature files. How we can open one? If you want, for example, 10 to 40 degrees. Just take
Open. File, open.
file,
Template,
Template open.
open.
So here we don't want to change. So
Yes. Then we will go for example 15 to 40. Then save it, right?
yeah.
Then this one has to see the already exceeded the
Oh, you are saving.
Yeah. Now how?
So what you?
No, example now.
Okay, if you don't want to save it, just go cancel, and then it will open up the. Then open.
Then
Okay.
open. No.
No,
You
that's it.
open. File, template,
Okay.
open.
Okay.
Then no. You have to say no, and then they're open.
Open. This
Yeah,
one.
and then open. Yeah, that's the step.
But also, that's one way of doing it. If you've got a number of templates you continually use, if you go to File,
File.
File, File History,
Okay.
this top half shows the current tests which have been run,
Yeah.
and also the bottom here is the templates. So if you're going between 2 or 3 different templates, you can use this file history to recall your template instead of going the long way. And if we cancel that and see here there's a little down arrow, if you click on that, that shows the history as well. So that's just a fast way to reselect your templates.
So now this is existing template, the one you open now.
Yeah.
So if we don't want to change this one, so we'll make save as or
Yeah, if you don't want to change this one, or you want
no, the one you open now. It is existing template.
Yeah.
Yeah, so if you go back to general, and you'll see the current template is this one.
Yeah. So if you don't want to adjust this one, I want to save as.
Yeah, you can just save and rename, save it back to this template. So just overwrite that
Sir,
file.
go file, then template.
Remove your hand.
Save as, we will save like new files. We can different temperature. Right?
Or just save the current template and save your changes.
It is different temperature.
Yeah. So that way, all common parameters you don't have to change every time. You can do them in one template file and easy to recall. So the main, if you go back to setup and control. So here's the frequency range the machine can operate. So from 25 Hertz up to 0.1 Hertz. So
Which frequency?
We'll need to check on the current standard. I think calls for 3 or 5 frequencies. You know, you may wish to run all frequencies depending on what you wish to do. So the software is flexible. You can untick a frequency so it won't run that frequency. This next section is where there's specimen information. So we have, if you're doing a number of markings on the sample, you can measure heights at different points and then enter in the diameter and height here. We'll give you an average and a standard deviation. If the sample is not very level and you're getting a standard deviation past the tolerance, then you may have to reject the sample because you need to be fairly level sample. So you can use this to check how good your sample is prepared.
So how if I want to check now? Is this coming?
Yep. So say if we had one reading would say 99.9 and press enter or text box.
That means today morning you told me to that sample we will take it this one. Before we will make it that lines and this line, and then we will take it this height, we will enter here.
Yeah.
Then this side height we will enter here. That means 4 area and diameter also top, middle and bottom like that. We will enter the 4.
Yeah. And if the standard requires more number of points,
then we can get the accurate or average.
Yeah. So you can take up to 6 points per sample for height and like
6.
The gap there is normally 70 millimeters.
No, again, this point 2. So what will be done? It will be integral or this is the diameter and height, the first one.
So the first one is diameter, so 100.
Okay.
And
So what about the second one?
Second one means, sir, this one first we will take the top diameter, then some places like that in the
You
sample.
could measure,
Different places and enter the menu.
So is it required to fill these things or we just
It depends on the standard. Do you know offhand how many points? Yeah. So we can check if we get a copy of the standard and check on the preparation. So for this test, then you enter your, or you can also the conditioning time and any properties about the material. You can also put into here. So if it was conditioned for 2 hours, you could put 2 hours in here, 2 days. So you enter information here.
Then target temperature. We have to enter manually target temperature. Example, I need target temperature 32. I have to enter 32.
Yes. And if you wanted to do a confining test, then you would enter in your confining pressure, maybe 50 kPa, 100 kPa.
Yeah, target.
So you target.
how much this?
Typically they run at 50 kPa confining pressure. Again, it depends on the
capacity.
Machine 50 kg.
This can handle typically
450.
210.
450.
It's rated for 400 kPa the chamber. There's a relief valve here which will relieve any pressure in excess of 275 kPa. So the chamber's overrated, but this will
Open it.
blow out. Yeah,
Automatically will open or?
yeah, there's a little bit hard to see there because a safety relief valve.
Okay. We will.
So that. And for the dynamic modulus test, the test tries to target 100 microstrain, and to start the test, the operator needs to sort of be familiar with the material and sort of enters an initial modulus value. So by using that value, the software will automatically try and compute how much load do I have to apply to target 100 microstrain. So if you put too high a modulus, the system may put too much load on the initial sample. So you need to sort of have a feel for what you expect the material to be in this section here. And then there's the standard gauge length is 70 millimetres for this machine. If you're using, say, UTM 125 or 100 and doing non-standard testing, I think there's one customer who's using 100 diameter gauge lengths, so you can change the range. But for this machine, they're fixed at 70. So all you would need to do is enter your initial modulus, estimated modulus value. If you're doing fixed frequency temperature ranges, you could save your different templates with these parameters in there, so you don't have to continually re-enter all your information.
The gauge length is here.
Yeah, so 70 mil gauge. And then there's a tick box here, which if you tick this, it uses the standard test methods. So for when the sample, before it applies loading, it uses 5% of the expected dynamic load as its seeding load. Because if you had no seeding load, then the sample would just fall there, because you need some load to hold it in position. So the standard says typically 5% of, say if your deviated stress was 200 kPa, and 5% of 200 is 10, so we'll use 10 kPa seeding load just to maintain contact on the top plate. So if for some reason you want to do some non-standard testing, you can change these parameters. And if you leave it ticked, then it just uses the standard.
So now it has 5%.
Yeah. And also,
you can adjust it.
yeah, so if you untick that,
Then can adjustable.
yeah. And also, the standard sort of says they want to target 100 microstrain, but it can be quite difficult to exactly get 100. So they specify a range. So as long as your strain is within 85 microstrain and 115 microstrain, the standard says you can accept that data run. So typically it tries to target 100 microstrain. You may only get 95, or might get a little bit more depending on how your material reacts. So as long as it's within the range, then the test results.
But if the initial load that you have to apply 5%,
yeah.
but the load rate is how much?
It depends on the material and the modulus.
This one, sir, I can know that we will apply the load here. It will be the sample will be failed.
No, only 5%.
This one might
automatically will be stopped after the test.
Yes. Automatically stops and goes down.
Sample will be there, the vendor will be the test. It will be automatically.
Yeah, failed.
The dynamic modulus test, it's not a failure test.
It's not a failure. The test itself actually is almost like elastic in that you will apply the frequencies, loads, and you release like that. So you are not going to load the sample till it fails. The sample will keep its shape. You are
Same
just trying.
condition
You are just trying
different environmental conditions.
different pulses and different temperatures.
When you would start,
They will apply the load and release it.
Yeah, it's not a failure.
Not the
and you would start with the cooler temperatures first, because you run those tests, take the sample out, put it back in the oven, take it up to the next temperature.
example, we will start at -4 or something.
Yeah,
But
yeah.
up to 60 degrees, it will be automatically.
Yeah, because you're trying to keep the sample in its elastic region, I guess.
That means we will enter here low temperature, high temperature, or
Yeah, so
low temperature, high temperature we will enter. Low temperature example we will enter here
yes.
4, and high temperature we will enter example 60 or 50. managed automatically in
It'll adjust, yeah,
chamber,
yeah.
right?
So what you would do if you're testing, say, 5 or 6 samples, you do all them at the one temperature, then you come and change to your next temperature range, let the chamber heat up, and also your samples will need to go back into the oven.
This will be enough for only one temperature, the setup.
You're going to just,
For only one temperature.
well, if it's just one temperature, then yeah, you just,
Then after that I have to again start.
yeah, so you put the sample back in the oven, take it to the next temperature, then you can,
I mean, we cannot do automatically different target temperature. I have to make one
Manually,
yeah, it's all manual.
one by one.
Yes.
Yeah, example, I will test here 4 degrees temperature. Okay.
Yeah.
Then that on finish testing, I have to keep again sample it. Example 25 temperature I want to, I will have to put it in oven and
Yeah.
warm up the
Yes.
sample and again we have to bring it.
Yes. So say if you had 5 or 6 samples, you do all those samples
Yeah,
at
because
one
you have to
temperature,
pick the condition.
put them back into the oven.
Yeah, that means same casting sample, same as before.
Yeah.
For example, we will cut it 5, 6 core and different temperature we will different sample we will test them, right?
Yeah, and you go from the low temperature to the high temperature.
That
So,
always to go from there.
yeah, if you start at the high and it's very soft material, you might.
Yeah, that means one sample cannot go for different temperature.
If you were doing one sample, you could
can't.
use this to condition, but if you're doing many tests, then you need to get all of the samples up to temperature quite quickly. So if you're just using the one sample,
We will start from the cooler one, then for example 4, then we will adjust to 25, we will wait till it's conditioned here.
yeah.
And after that we just can be done.
No need to put it in oven, we will wait it for inside the machine.
You can keep it in here, but if
But
you're
how
doing
many
many,
days?
many samples,
1 to 2 days to condition.
Can be conditioned here also.
1 to 2 days.
But it
How
will
many-
take time.
yeah, it will
Depends
take
on
time.
depends
Yeah.
on the temperature.
but you can only
Yeah.
condition one sample.
Also, you should remember that most of the tests you have replicates, 3 to 5 samples. So you want to run all your tests for all the samples at the same temperature before you move to another temperature. Because you don't just run for one sample, you run for
3 samples.
5, 10
Yeah.
samples. So
So you
all the
finish
samples
first
you
3
condition
and then
you run the test, you finish.
Yeah, we can keep it in oven and
yeah, we cannot
that-
condition
that-
only
that
one
get the
sample.
warm up.
We have to
That's why
condition
this
3.
one is different, because this one you can put all your samples in while you're testing one.
Yeah, there is a extra
Yeah.
layers of
Yeah.
Actually, this one also can be used for conditioning, right?
You
Yeah.
can, yeah. So you could use the
Yeah.
chamber there if you're not using that apparatus.
Because maybe better than the oven.
Yeah.
What is the day?
Okay, so
Then test it.
so when the test runs, it computes the dynamic modulus, the phase angle, and gives a number of quality factors, again, which is defined in the standard. Quickly jump to this tuning section is more for if you're not getting very nice wave shapes, the material, what we call PID tuning. So we've got what we call proportional gain, integral gain, and derivative gain. It's more for controlling the feedback of the system. So in the standard here, ideally you want to have a nice sine wave loading, and the standard says you've got to be within 10% of the load standard error. So in an ideal sine wave, and you get your feedback, your sine wave will never be exactly the same as in theory, but you need to try and get as close as you can to that. So there's what they call load standard error. So it's working out the difference between the ideal wave shape to what the actual feedback system is applying. And by adjusting these parameters, it can improve your wave shapes. So a lot of the time, this is, you can use it on one sample to check your wave shapes. And we'll do this maybe after we have a small break and can show you the effects of the different settings. So it looks quite a lot of information in there, but a lot of the time, if you're using materials which are very similar, you don't need to keep changing all these parameters.
This is 25 hertz. There is 1900. It will automatically go into 50.
And in the future system, I want to set this up so it's all automatic, so the tuning the system can be done automatically to improve your performance of the machine.
If you want to change, you can change it with another
So, there is a 3 point.
Yeah.
So how's our time? Do you have to stop for a coffee break or anything?
Yeah,
guys, or-
yeah.
What we can do, maybe we'll just run a dynamic test, and then we can have a short break. And if there's any questions or anything, and then we can do some more testing after.
For this tuning, depends on the mix. So how are we going to identify? For example, I have for certain template, and I have
You can have different templates for different mixes, and generally this proportional gain value is the like an amplifier, like on, say for example on the car radio or your radio. By turning the volume up, the music gets louder. With this value, the higher it goes, the quicker it responds. But like say in the car, if you turn the radio too much, it just starts distorts and all crackle and everything. The same effect can happen here. So you sort of adjust it so you're getting a nice quick response.
So this thing, I will do it after I finish the after I see the output.
Yeah.
If there is
Nakatatlong
issue,
ang camera
I
na.
have to just
You can adjust it
May
slightly.
tapos ng plan.
We can recommend, if you send us a
Wala na.
data file,
Yung sa
we
kanya
can
wala na.
see, increase this a little bit.
Sa laboratory.
It's sort of advanced sections, but some people, want to know how to control function nodes and that. So, did you ever work on the PID tuning or anything? Or?
No, that's one
And a lot of the times we find the seed values which we have in the templates is fine, and some people you never need to go into here to check.
maybe it will come by the experience of testing. After
Yeah, exactly. Yeah.
we see how the output.
Yeah. And maybe the next 1 or 2 days when we can have people playing on different machines, we can show some people who are interested in the tuning,
Tapos na siya.
and I can show the effect of what happens. So anyway, so if we just run this test with these values, do you remember what modulus we had last time in this material? Or?
This one 40 to 60.
This is when we
Tapos
ran.
na yan.
So it's about 2,000 MPa. So if we just put an estimated value of 2,000 MPa,
2000 megapascal, right?
yeah. This sample we had in here back in April when we had the open day of the complex. We ran some tests here, and I think we got the 25 hertz was around 2,000 MPa modulus. So if we put that value in as our initial seed value, so if we now go, when you're ready to start your test, so you check your levels to make sure your transducers are in the range. You can check your temperature to confirm that your temperature is in your range.
Okay, examples of this one, level. We
Okay,
will
so
click
your
it level. This translation says this level is suitable or
Yep, so we have 32 degrees on here. We look at our
32 degrees,
thing,
it's okay,
so it's,
inside okay.
so
Then the sensor will be point, someone is different, 0.038, someone is 0.054. It's
that's
okay.
okay. Yeah. The software with these transducers, when the test first starts, it'll take a reference value as those current points. So you don't have to take it to zero.
From current point to
Yeah, so it'll use that initial point as a reference.
To give the net value.
net value, that's mean.
Yeah,
Net value,
yeah.
that's mean is
And also here, while the sample is down, it'll zero out the load cell because the sample will weigh on the load cell. So the motor will see a little bit of 22 newtons on there, which is the weight of the sample.
Yeah, that's
So-
mean is sample weight, that one will be top of
And that
the
will
load cell.
Will automatically be zeroed out. So if
But when we will start at that time, it will be get automatically zero, right?
yes,
Load cell will be.
yeah. and then it'll apply the contact stress. So if you now go start test, so someone, and then you can enter in a
The file.
file name.
Examples.
Try a little bit.
Yeah, one. We will say one. Where it will be saved data file.
At the moment it's in the data folder. You can make a new different folder.
Okay, we will save.
Okay, so now here you just wait. At the moment, see this is going up and making contact.
Then we will make it.
So, first of all, before you hit OK, you check here when it's in range, and then it'll go for the frequencies. So it's showing the 3 transducers and your dynamic loading.
The red one is the
Red is the
dynamic
dynamic stress.
Oh, okay.
So in this test, for each frequency, it applies 5 pulses initially, and based on your initial modulus, it calculates what load it thinks it needs to apply to target the 100 microscope. And if it's different, then it readjusts it automatically, applies another 5 pulses as a preconditioning, and then 10 pulses for the test. So for each frequency is only 20 pulses are applied, and it uses the final 10 for its calculations. And you'll see up here the different frequencies, the dynamic modulus, the phase angle.
That means the difference was 25 or 20.
Yeah.
It will get.
Yeah. And you'll see at the different frequencies, the modulus is very different. And the main one here, this load standard error needs to be, I think, below 10% to be valid information. You know, if for some reason this wave shape is not a sinusoidal, then you may need to reject the
How many percent?
10%.
10%.
10%.
This is error, right?
This is the drift, right?
Error. This one now.
What do you call the drift, right? This is down, the drift? Load drift?
Yeah, I think the low drift, I think, was for any, you know, if you're not maintaining your right level, let's say if it's sort of, your load's dropping off, it might be like a drift in the...
So standard error should not go over the 10%, right?
Yeah. So with this the IPC machine, we can get very good load error. I think initially they had the specification for 5% and under, but some of the other equipment manufacturers weren't able to comply under the 5%, so they relaxed it a little with 10%.
How can we verify the software calculation?
All the data here you can export into Excel, and you can
We can
manually
export to the Excel, right?
Yes.
Then we can identify how it will be calculated.
IPC will not provide validation of the software.
We have what's called a proving verification ring. That's a device which you can put in
Here
to check, to check if the system's operating correctly. So as long as you've got the correct calibration files matching the transducers, then you should.
And you will tell us how to do it.
Yeah, we'll do that in training as well. So here you can see with the very slow frequencies,
This will take more time.
and then the in the 0.01 it takes 100 seconds to do
It's
one
okay
cycle.
to have the pressure, but it was 0, right? Before. Confining.
Yeah, we didn't put confining, so if we had confining we would have applied the pressure again. So
It was showing 0.3.
yeah, it was still that's okay, but it's 0.3 is probably just some circulating air going on. If we were targeting 50, then you should see the 50. So I think in the specification, as long as it's half a plus or minus 0.5 kPa, we can tolerate the target. See the temperature maybe, because we had 20 degrees entered in here, you can see the warning for the temperature is 32. We should have put 32 in, so that can indicate too that you're out of your temperature range.
Well, again.
You can go back and edit it? No.
I don't think you can edit once it's...
Can you show this again?
Yeah, if you go back to...
What about the temperature?
When we started, we should have put 32.
I
Because-
think you put it before. No?
I put it before, after that again changed.
No, because this template is 20, I think.
Maybe we
We may not save the template. We might have changed it.
We got temp files, there will be the what the temperature will come automatically here.
Yeah, so
So we should have changed it.
saved it in the template. So.
So this one is showing.
That means we have to create at one temp files and we will put it our temperature, whatever
can, yes.
the range. Huh?
Yeah.
So it's done?
That's still going. If we go back to the, we're still in the 0.1 hertz.
By the way, you mentioned earlier, you can use this for the licks.
Yeah, if we put a membrane on with confining pressure, which we'll do maybe this afternoon or tomorrow, we can show you that. So we have some membranes here.
But usually why we need the membrane sometimes? Or the confinement?
If you're using confining pressure.
Sometimes you need to test the sample without any pressure this side. Sometimes you need to apply pressure to simulate the actual heat. So this is the confinement.
That means we have to cover on the whole sample by this rubber, right?
And this device here also can apply vacuum, so you can suck the membrane off and then put it on.
Yeah, that's when I see that unit, right?
Yeah,
We
this
put
one.
the chambering
Yeah.
rubber here and the suck and then fix.
Yeah.
But what about after chambering? We cannot fix the clips, right? Can fix on the rubber?
No, the
surface?
rubber will go over the membrane and you can clip the...
That's when we have to open the.
Yeah,
He
and,
will demonstrate, no problem.
yeah, we'll do it.
He will demonstrate it.
Near to the edge of road, for example.
Yeah.
If you have something special, you need to verify. The confinement comes from the adjacent area. Sometimes you want to test without confinement. Because the confinement will help the sample to take the vertical load. Of course, if I have sample, I apply vertical load, and if I'm making the terrain like that, it will be more strong.
It's strong,
if
yeah.
I remove, it will
Yeah,
be
that means
That's
it will
why
be
you should check different confinement
different.
to know what is the
But examples are road center we will cut. There is a
confinement for every place.
Every
Sometimes if you want to check, for example,
Yeah.
something near the edge.
that means it's like similar to the road. We can check on the.
This is the confinement. And the amount of pressure also, you can, why you want to check different? You check different because sometimes you have less confined, sometimes you have more confined.
Yeah.
Depends also on the temperature. If I'm having very high temperature at the road, the confinement will be less because the asphalt will be
Soft. Yeah.
So now it's doing the final frequency, which takes 100 seconds to do one cycle. So this takes a bit of time. Should we have a break? Yeah, so we can leave this running. So when this finishes, it will automatically...
Will be stop.
Close down.
Automatically will be stop, sir.
Yeah.